Should have a short one this time. This isn't a repeat of what we did last time. It's similar to what we did last time, just taking it one step farther. Instead of starting with the velocity curve for a particular situation, we're starting with acceleration. So we know the acceleration of whatever this thing is, particle moving on a straight line, over a time period from 0 seconds to 6 seconds. And we want to know, again, the distance and the displacement. So first step is to find the velocity in terms of time. We know acceleration is the derivative of velocity, so velocity is the antiderivative of acceleration. And that's going to give us 3t minus t squared over 2 plus c. All right, we know the acceleration at every moment in time, but we don't know how fast this thing was going when the situation started. If we knew one velocity, then the acceleration would tell us the velocity at every other moment in time. So this is one of those initial value problems like we did at the very end of chapter 3. We need to know a velocity so that we can figure out what that c is, so we can figure out our distance and our displacement. So in the first half of this problem, we're assuming, or we're told, that the velocity at time 0 is equal to 0, which means if we put a 0 in for t, this thing has to be equal to 0, which means that c is equal to 0. So to find our distance, we would do our integral of 3t minus t squared over 2 from 0 to 6. So that gives us our displacement, right? So we put this in our calculator, 3t minus t squared divided by 2. Graph that. And our second calc 7 from 0 to 6. That gives us our displacement of 18. So our displacement is 18. And that happens to all have been in the positive direction. So that's also the distance we traveled. There was no positive and negative to cancel each other out there. Both our displacement and our distance was 18, whatever thing happens to be, or whatever the units happen to be here. Now, what if we had assumed instead that our initial velocity was 4? See, if we look at this, our velocity went from 0 up to something. Looks symmetric, so assume, well, it is symmetric, it's a parabola, right? So at 0, the velocity was 0. At 3 seconds, it was 4.5, and then it was back down to 0, all in the forward direction, and our distance traveled and our displacement are 18. What happens if we assume that our original velocity was 4? If we go back to this, that just means that our c would be 4 instead of 0. So we go in and put that into the calculator, plus 4. And before I hit enter or graph, what do you think that's going to do to the graph when we add a constant to it? It's going to shift it vertically, which basically is going to add a big rectangle underneath that shaded area. It just moves our parabola up, and then when we do our distance, second calc 7 from 0 to 6, our area is going to be exactly the same, right? Our old area was like that, 18, and we just slid it up. So we inserted a rectangle underneath it, and the rectangle is 4 by 6, which is 24. If you add 24 to 18, you get 42. All right, so starting with acceleration to find distance and displacement, you got to do the antiderivative twice, once by hand, and then put that one in the calculator and let it do the work. But the other thing you have to remember is you need an initial velocity in order to get the correct constant to get the right distance and displacement. And that is it for distance and displacement.